All right, so we're going to start looking at servos today. So a servo is a kind of motor, and it means different things in different contexts. But in our context, it's a tiny little motor that has a short range of motion, and so it's useful for making things move over a short range. So in this case, we have these servos that move 180 degrees. So you have an arm on it, and it can turn kind of like down like this, and then back. Okay, and so the first thing we'll take a look at is wiring the servo. And so we're going to connect this brown wire to ground, okay? We're going to connect the red wire, not to 3.3 volts, the positive there, but we're going to actually connect it directly to this top one called V bus, because that's actually 5 volts. So I got to be really careful here that we don't connect that V bus to anything else, because we can break some things. But for the purpose of the servo, it's going to make it work better if we run it on 5 volts instead of 3 volts. And then finally, this last one is the kind of the control or the signal to control it. And we're going to run that to pin 16 here. Now, the way that a servo works is it's essentially got its own little microcontroller in it. It's got a motor, a microcontroller, and a potentiometer. And it's basically what it does is when the motor moves, the potentiometer turns, and the microcontroller takes a reading of the position of the potentiometer and gets that analog reading and compares that to its expected position, and then it kind of moves it until it gets to that position. And so it's basically a way that it can keep track of where it's at and kind of go to where it thinks it's supposed to be. And the way we control that is by sending a pulse width modulation, right, PWM signal through here. Okay? And now the process of that is actually a little bit complex. And so if we look here, this is the library that we're going to use. But basically, we have to do a calculation to basically generate, by passing an angle, we have to generate like a duty cycle for the PWM. Okay? And anyway, without having to get in the weeds of this, instead we're just going to copy in this servo.py file into our project, and we're going to use this in the back end to control the servo for us. Okay, and so what we're going to do is you're going to open up this link, and you're going to just go here to copy the raw file. So you're going to copy that data, and then in Tawny, what we're going to do is we're going to make a new file. So we're going to go new, then we're going to go to save. We're going to save it to the Pico. We're going to call it servo.py with a lowercase s. Okay, and we're going to paste in that module. Okay, so now that we've done that, we'll save it. All right, and so we're going to leave that file there, and now we're going to make another one, and we'll call this one servo test.py. Let's see, save, Pico, servo test dot. Oh, here, let me get rid of that. Okay, let's save it. We'll call it servo test.py. And then we're going to generate some code. So first thing we're just going to import our servo library. So from servo import servo, just like that. And we're going to make our servo object. We're going to create an insert instance of our servo class. And we'll set our pin equal to 16. Okay. Now we can also set some other things, the frequency and the min and the max microseconds. But and then the max number of degrees, but we're gonna we'll leave those blank here because we don't really need those in our case. Okay, and then all we do here is we say while true, and we say servo dot what's our function? Servo dot set. Yeah, let's make it right. There we go. So we're going to say servo.right, and then here we just pass in an angle between 0 and 180. So we can write it to 0, servo.right, 180, just like that. Let's import time, and then we'll say from, sorry, time.sleep. So sleep 1 second, and then we're going to say time.sleep 1 second, like that. Okay, we run this, and if you have it wired correctly, I don't know if you can see it, but you have the servo kind of swinging 0 to 180 degrees. Okay? And you could try changing those delays. If you make it too short, it won't move at all, stuff like that. So the next thing we can try, though, is we're going to, instead of this, let's do a servo sweep. So for I in range 180, we're going to say servo dot right, and we'll write that angle. And we'll say for I in range. How do we do it backwards? Let's see. Okay, so what we're going to do is we'll say the 180, and then there's a function we can use to reverse it. And so we're going to say reversed, just like that. And we'll do servo dot right. And so we'll add some short delays. We'll say time dot sleep. Maybe put a 0.1 there, and then in between we'll do a longer one. Time dot sleep 2. And let's copy this as down here as well. And so this is going to give us a sweep function. You see it doing the sweep kind of slowly. Probably too slow here. Let's make it a little faster. So let's go with 0.01 and 0.01. Let's try that. There you go. We got that servo sweep going on. Kind of rough and rattly, but it's doing the job. Okay, and so here we're controlling servo.